Hello, this is the video for Lesson 7-1A, Measures of Center and Variation. And in today's lesson, we are going to learn about mean, median, and mode. And then we're going to talk about range and standard deviation. So the first three are specifically measures of center. Now you need to know the difference between measures of center compared to measures of variation. So we're going to talk about measures of center first. So if you have your highlighter out, go ahead and grab it. So measures of center basically describe the typical value of a data set. Now, it doesn't necessarily always have to be the mean. Yes, that's the most important one that you use on a regular basis to figure out your grade average. But a lot of situations in the real world, we use the median, and in the mode, we use it to describe most of the time things that are not numerical. Okay, let's talk about the first measure of center called the mean. And you've used the mean before. Now, it doesn't say so in your notes, but the mean is the balancing point of the set of data. So if you were going to graph it on a dot plot or histogram, the mean would be the balancing. You would have the weight on one side match the weight on the other. So the mean is heavily affected by outliers. So if you have something that is really, really big compared to a lot of things that are small, what it's going to do is it's going to make the mean go much higher than it should. Therefore, it doesn't really represent the data very well. And the reason why you do that is because you just simply add up all the numbers. So it's the sum of the data divided by how many that you have. So you got to make sure you divide that. And just make sure that you highlight that it is definitely affected by outliers, and you're going to see that later on. Okay, the next one is the median. Now, the median is not the balancing point. The median is literally halfway in the data. You've got 50% on the left and you've got 50% on the right. Typically, if you have an outlier, the median is going to be the best one to use. So then you have the mode, and the mode is typically for categorical data. That just means that it's not numbers. I've never seen them use the mode to represent numbers. That's not true. Maybe they can do that. They're just looking for the most of a number, but typically if it's just like an average of something, they'll use the median or the mean. Okay, so now that we've talked about them, let's go ahead and do an example. This one is an amusement park, and they've hired students for the summer. The students' hourly wages are shown in this table. I don't know who's making $16.50, but that's pretty awesome. So you've got, looks like you've got 8 different numbers here. And if you were going to do this by hand, what you would do is you would write all of these numbers out and you would add them up and divide by 8. I'm going to pause the video. I'm going to do that. Okay, so I've gone ahead and I've written it. I ran out of room, but whatever. So you're going to add all of them up and you're going to divide them by 8. And if you round to 2 decimal places, you wind up with $9.65. So the balancing point would be $9.65. And I think that does represent the data, but probably not as well as the median. So the median, what you have to do is you have to arrange them from least to greatest, and you have to find the number in the middle. So I'm going to go ahead and arrange them from least to greatest. So pause the video, you go ahead and you do that too. Okay, so I've got them all listed out, least to greatest, and I started marking them out, the bottom 3 and then the top 3, but then I realized I've got 2 in the middle. So when you have 2 numbers in the middle, what we want to do is we want to add them up and we're going to divide by 2. Basically, we're taking the average of these 2 numbers. And that's going to be equal to 8.7. If you, well, actually, I don't think you have to round it. Okay, next up we have the mode. So if you've got your numbers already listed from least to greatest, you can kind of tell that I've got 2 numbers that are repeating. Now you got to remember the mode has to be something that occurs more often than the others. So if everything is there twice, then it doesn't count. So it's absolutely possible for you to have no mode. You can have 1 or you can have multiple modes. In this case, I have 8.25 there because it is there twice more often than the other ones that are there once. Now let's get into using Desmos and how to find the mean, median, and mode. Okay, so in this section, what I'm going to do is I'm going to have you find the mean, the median, and the mode using Desmos specifically. So one way that you can type in a data set is to use a capital letter, any capital letter. So I'm going to use a capital A in this case. I'm going to hit equals, and then I'm going to do brackets. And then I'm just going to enter all 8 of my data values right here. Do not use any dollar signs. And then all you have to do is just use a comma to separate each number. So pause the video, go ahead and type in your data. So something really neat about this is that it will show up automatically that you have 8 numbers in your data set. And just underneath it, you're just going to hit mean and then open parentheses and whatever you called your data set. So I called it A, so you're going to type in A, and then it's just that easy. This is really handy if you need to do multiple things, like if you want to find the mean, the median, and the mode, and you want to like transform that data, which you're going to learn about in 7.1b. So it's really convenient. So this is how you do the median. You just type in the word median and just put an A in there, and it will just tell you the median automatically. So the mode is different on Desmos. It does not work very well. There's sometimes when you might be able to use a dot plot if your data set is big enough, but in this case you only have 8 numbers. Sometimes, I'm just telling you, sometimes it works, sometimes it doesn't. Let me show you what I'm talking about. So you can do dot plot A, and there is this big mess. It is not arranging it the way it should. It should have like all of the first occurrences right here on the same line, but it's got this one way up here, and I don't know. So dot plot is unreliable, so just do the mode by hand. All right, let's talk about an outlier. So an outlier is a number that is going to either be much greater or much less than the other values in the data set. It's going to look like or feel like it just doesn't belong. And in this lesson, you're going to be able to kind of just look at the data set and find the outlier. So there's a group of 8 people that work together, and their annual salaries, range from about, 32,000 up to, oh wow, okay, so 72,000. So do you see how that 72,000 doesn't fit in with the rest of the other salaries? That's definitely going to be our outlier. How does it affect the mean? Now, if our outlier is greater than everything else, what it's going to do is it's going to make the mean increase, okay? And that's why if you have an outlier in a data set, the mean is not going to be the best measure of center. If you do have an outlier like 72,000, it would be best for you to use the median, because the median splits it into halves instead of using a balancing point. Okay, so it's going to make the mean increase. Describe one possible explanation for the outlier. Well, it's probably going to be the supervisor or the boss. All right, now what it's going to do is it's going to ask you, how does the outlier affect the mean, median, and mode? So what we're going to do is we're going to use Desmos, and we're going to type it in, and we're going to use mean A, and then we're going to do median of A, and then we're going to have to do the mode without Desmos. Now look at the mode. Is there anything that repeats? That's pretty easy. 38,000. So I've got a 38,000, 38,000. So that's our mode. Okay, and so this is including the outlier. Hold up, lost my location. All right, go ahead and pause the video. I know that you're watching the video, and I know that you want to watch everything, but it's really important that you actually type this in so you can remember how to do it later in the future, especially on your end of course. So go ahead and type it in right now, and we'll do this together. Okay, before you type it in, I'm sorry. Do not use commas when you're typing in your numbers unless you are using it to separate them. So that should be the 32,000. If you use a comma here, it's going to think it's 2 different numbers. So, all right, now you can pause the video. Okay, so I've used only commas to separate my numbers. I've got 8 elements in there. Let's go ahead and type in the mean and the median. Okay, see how easy that is? Oh yeah, I use capital A. There we go. So we're going to go ahead and jot that down on our notes, and then I'm going to just delete the outlier in our data set and then re-record the mean without the outlier. Okay, now that I've recorded all of the information, I'm going to go back over here to Desmos, and I'm going to take out the 72,000, And let's see what happens to our new mean and our new median. All right. Okay, so looking at our new data set, since the outlier was not the mode, it did not affect that at all. So the mode's the same. The mean, on the other hand, looks like it has dropped by about 4,000, a little more than 4,000, and the median has dropped by about 1,500. So you can kind of see that the mean is greatly affected by that outlier versus the median, and that's why the median would be the better choice for the measure of center with an outlier. Okay, so at this point in the lesson, what you need to do is you need to stop watching this video and you need to go to Google Classroom and click on the standard deviation video. It's very difficult to just kind of tell you what standard deviation is unless you just kind of see different examples of it. Let me show you where to find that video. Okay, so if you navigate to your Google Classroom, just click on March the 4th or whatever day it is today that you're learning this lesson, and it should be posted right here. Now, if you don't have access to your Google Classroom or if you're not part of the Google Classroom, you can search this on YouTube. And you can just search Standard Deviation Explained and Visualized. It's by Jeremy Blitz Jones, and it's a little less than 4 minutes long. It's a really great video. Go ahead and watch that right now, and then after you're done with that video, let's go back to the notes. So now we're in that part of the lesson where we're going to talk about measures of variation. So this is different from the mean, the median, and the mode because you're trying to figure out how much your data varies. Now there's two major types of variation that we talk about in this lesson. You're going to talk about more later on. We have the range, which you have already studied before. The range is basically where you take the maximum number and then you subtract it from the minimum. So your range is all of this, the distance from the max to the min. And then you have something which is new, which is your standard deviation. You watched the video on that. Basically, your standard deviation is found by, just kind of in a nutshell, you're going to take the mean of all of your data set and you're going to subtract each data set from that mean, and then you have to square it, and then you have to like add them all together, and then you have to take square roots. Like the formula itself is pretty complex and time consuming, which is why we want to do this on Desmos, okay? So the standard deviation basically tells you how much it differs from the mean or varies from the mean. So the bigger your standard deviation is, so the larger it is, the more spread out it is. And the smaller your standard deviation, the less spread out it is. So this is what it looks like if you have a large standard deviation. It means that you've got, this happens a lot when I'm teaching in my classes and we take a test. I've got some people that have really high highs and then you have really, really low lows. If you had a class that was more consistent, let's say that they are like my honors class is a little bit more consistent. Most of them are scoring within 20, 30 points of each other. So they would have a smaller standard deviation. So on your notes, you do need to actually fix this. When you type in STDEV, yes, that is standard deviation, but what you want to do is you want to do STDEVP. And that stands for your population standard deviation. Like I said later, you're going to learn in statistics the difference between your sample and your population standard deviations. So you're going to do the population standard deviation from now on. And then to find like the maximum and the minimum, you can either look at your data or you can just simply type in stats, which gives you your 5-number summary, which is super, super convenient. Okay. So we're not going to do any of this by hand. We're going to have a little bit of help using Desmos to find the range, but other than that, it's going to be completely Desmos. So you've got 2 game shows. They select 12 contestants each. The ages of the contestants are shown in the tables. Find the range and the standard deviation of each show, and then we're going to interpret. Now, it's kind of like a little side note here, but interpreting is really important in statistics. So we're going to run our statistics here, and then we're going to leave this blank space right here to interpret. Okay, so pause the video. I want you to type into Desmos all of your ages for show A, and you can name that one capital A, and then type in all of the ones for B, and that will be named capital B. All right, I've got the ages for show A and B typed in, And I'm going to go ahead and find the standard deviation first. So we're going to type in STDEVP. Now, like you did for anything else, if you forget the word, you can click on your keyboard, go to functions, and under the statistics, you've got everything that you've used so far, the mean, the median. You can type in min and max to find those, but here's your standard deviations. You got STDEV. This is for a sample standard deviation. You're not going to use that one. You're going to use this one, STDEVP. So all you got to do is just click on that. So either way, type it in or click on it, and then that's for A, and that's for B. I'm going to write those down in just a second. Let's go ahead and run stats for A. I just kind of want you to get used to doing stats because we're going to use this in lesson 7.2. It gives you lots of information. If you want to find your mean, all you have to do, not your mean, but your range, you're going to do your max minus your min. So write down 52 and 19. We'll do that in just a second. And then stats for B. Got to spell it right. There we go. And that gives us our maximum and our minimum here. So we're going to go back to the notes and we're going to write all this stuff down. Okay, remember for the range, we're going to do the maximum of 52 minus 19, and that's equal to 33. So the difference between the max and the min for show A is 33 years. The range for show B is 20. Okay, so if I was going to interpret that, I would say that the range for show A is greater than show B. Okay, so there's more variety of age in A than there is B. So let's talk about standard deviation. So for A, I wound up with 9.98. Now, since your range is bigger here, your standard deviation should also be bigger. It means it varies that far from the mean typically. And the standard deviation of B is definitely much smaller, 5.97. Okay, so interpreting is very important in statistics. So let's interpret the first one. So the typical age for show A differs. It's a key word, so you can say differs or varies from the mean by about 9.98. And what that means, I'll just draw you a little picture. You don't have to draw this picture. So your mean is kind of hanging out right here. So they would add 9.98, 9.98, 9.98. So most of your data is going to be, in this section right here. And then likewise, they're going to subtract 9.98. So technically about 68 is going to be here. 95 is going to be within the first two. So 95% of your data is going to be right here. That's what they're talking about with the variation. So if it varies by 9.98, that one's definitely going to vary more than this second one. So for show B, the typical age, that differs from the mean by about 5.97. So for that one, that would look more, I would make it a lot taller and less variation. So I'd have 1, 2, 3. Your standard deviations would be a lot closer to each other. And that's what it would look like. And just let me know if you have any questions.